I hope that didn't go onto YouTube. It probably did though, didn't it? Because of course it did. Yeah, it did. Okay, let me just put that on private because no one wants to see that. Save. Cool. And I think I am already live for the last 26 seconds. I think. I'm not used to this at all. You can clearly see I have no idea what I am doing. Okay, cool. I think we're all set actually. Cool. Well, okay. Hello, everybody, or anyone who wants to sit around and listen to me for. I'm gonna make this maybe an hour or two. I don't know. We'll see how we get on. But I wanted to today. Oh, you know what? Before we start, hold on. This is me doing things live. Wait, I should probably show OBS. Okay, that's Instagram. Let's go on Instagram. Yeah, I don't want to publicly tweet about this because then people will come join and pressure me into things. Okay. If you like trying out this is gonna be a more interesting stream, I promise. It's just I always want to share it on socials, but then I guess I should schedule it somehow or talk about it before I go live. To be honest, this is very spontaneous. So yeah. Okay. Right, so what are we doing here today? Oh, is my stream still going on? Yes, I think it is. And can you still hear me? Okay, there might be a little bit of a lag because I'm trying to make it, which is not optimal. Please check video resolution. The stream's current bitrate is higher than recommended. Oh gosh, do I need to change this again? Oh no. I really want to change that. Let's change this to... Hope I don't need to start a new one. I hope that's worked. This is not even me, I should have checked this before I went live. Because this is just not happening. Oh, it looks like it's all good now. According to this. Yeah. Oh, cool. It's working. All right. Okay, so when this stream comes out, I'm going to remove all of that initial stuff because no one needs to learn all that stuff. But yeah, this is me using my new camera and I'm really, really excited because it looks really good. I'm just a bit worried about battery life. I don't know, it could drop of me, it could start not working in the middle. Like I haven't been on a long enough like meeting or live stream to test if this is going to work, but we'll see. We'll see how it goes. Okay, so today I wanted to be very open about learning about Kubernetes and cloud native technologies because I am hoping to sit the KCNA, which is the Kubernetes and Cloud Native Associate exam at some point before the end of the year. And I've gone through the course, the Kubernetes and Cloud Native Essentials course, which is this one here. And I got it as part of like a deal when it first launched a few weeks ago. So that was all very exciting. And yeah, so this is essentially what I signed up for. And I'm really looking forward to like doing it because just a bit of background for those listening. I was a DevOps engineer once upon a time earlier this year. And as part of that team, I touched Kubernetes quite a bit. But most of the time, I like ran small kubectl commands that didn't do much like damage or didn't really affect anyone too much. That's why I sort of have an understanding of using Kubernetes to an extent. But I actually also challenged myself to try and complete the Kubernetes. Oh my gosh, I forgot it now. I wonder if they have it on here. Certification. Yeah, it was the Certified Kubernetes Application Developer exam. And I had that as one of my goals this year to complete. But I just couldn't, I just didn't have the capacity in me to do it. And I was wanting to try, but I just didn't have the capacity to do it. And also so many things in my life were changing at that point as well. So I was like, it's okay, I'll do it at some point. But yeah, so that's essentially what I did back in the day. And then now I'm in a like advocacy role. I don't actually need to touch Kubernetes as much, apart from when I'm on call. But that doesn't like, it's fine, like that's completely fine. But like a part of me has always wanted to complete a Kubernetes related a certification because once upon a time, this was the role I wanted to do. This was like the path I wanted to go into was in cloud technology. So I was like, hey, I think it is still important to get up to speed with things and to make sure that I'm learning as well outside of my like daily grind. So not just all the stuff I do as an advocate, but also and in community, but also making sure that I'm up to speed with things. And cloud native especially is a place that I want to learn a lot more about. And I haven't had the chance to really explore. So I've been connecting with a lot of people in the CNCF community, and yeah, that's been good. I've learned a lot from them essentially. So yeah, so that's what we're going to do today. Enough of my ranting. I actually did a similar thing with AWS. Solutions Architect Associate. I was very public about what I was learning, and you can actually go back, and this time last year I completed my AWS certification after months of studying and learning out loud. So that was super useful. And I sort of want to do the same thing because it's funny because I actually learnt a lot just talking to myself. And I think we sometimes get into this rut where we're just talking. We're not talking to anybody because we all like work from home or we're remote. And that's sort of where the world is moving towards. And so when it comes to studying, I remember at university, I used to study with other people around me, but now it's not like that. And so again, it always goes back to community, but it's very, very important. So yeah, today we're going to go through some of my notes that I've taken from the Kubernetes and Cloud Native Essentials course. And just, saying it out loud and sort of in front of people keeps me accountable. So we'll talk through that. And if in the middle of the stream my video turns off, it's because the camera battery died, because I'm still waiting on a battery for my new camera that stays on constantly. But yeah, we'll see how that goes. Okay, so Cloud Native Associate exam then. So like I said earlier, this came out a few weeks ago, so it's relatively new. And that's why actually I struggled to find extra resources. So if you followed me before in my certification journey in the AWS world, I did a lot of looking at other courses. So I went through a Cloud Guru. I went through the AWS training material. I also found Stefan from Udemy. So I made sure that I went through all of those different things, because I needed to reread stuff in different ways, and that's just how I learn. And I think it also helped when you go into the associate exam, the Solutions Architect Associate exam, where it's written in a really funny way. It's almost there to write, to sort of, not, it's almost as if they write it to try and fail you, because you need to reread it so many times. So yeah, that's why I found it really helpful, rereading things in different ways and listening to different teachers speak in different ways. Oh, I can see that someone's joined. Hello, Matt. Nice to see you here again. So yeah, that's what we're going to do today. Just talking through this and how, like I said, there's not much material on this. There's literally, it feels like just one essentials course that I went through in 5 hours. Smashed it all out, wrote all the notes, and I was actually surprised that I feel like I know a lot of it already. But still, it's important to go through it and not be too smug, I guess. I don't know, because I did a lot of Kubernetes in my old job, but still, I think starting with this certification first might be the nudge towards the right direction of going to the more advanced ones. Okay, so this exam is online, and it's also a multiple choice exam, which is a little bit better, I think, when you're, instead of writing essays and stuff of what you're learning, I think multiple choice is just so much better, because you can get into the right mindset of what could be the right question, the right answer. With that said, though, sometimes they do trip you up by putting all the same sounding words, I don't know, all these same sounding words and services in one answer, and then that sort of trips you up. But from the again, I haven't done a practice exam or anything. I've only done the online quizzes that was part of the course, and the way they've written it there was relatively straightforward, but I don't know what the actual exam was going to look like. But yeah, okay, so these are the sort of domains that you need to learn for the KCNA. So you've got Kubernetes fundamentals, which is 46%. You've got container orchestration, which is Docker, Podman, and there's another, I think there's another open source cloud native alternative. Maybe also learning the, what's it called? I've forgotten it already, but they're I've lost it. There's a name for it. I'm sure we'll go through it through the notes. So yeah, that's 22%. Cloud native architecture. So there's so many tools in the cloud native space. Just understanding how they sort of all fit in together may be useful. Oh, of course the sun is going in now, and I've just seen myself. Let me just try and close this. Does that make much of a difference? Maybe. Oh, it's always like this at my desk. We have I've got large window, and when the sun comes in, it goes straight towards me, and then I've got this massive monitor, so half of me is shaded and then the other half is just bright, which is like my forehead. but that's okay. Okay then. So then cloud native observability. So how do you observe your cloud native solutions, and how do you make sure that you have good visibility on what's going on? And then cloud native application delivery. I think, is that related to CI/CD? I think it is. Yep. But yeah, both of those are 8%. So essentially, I think the passing grade is 80%. So you really do need to understand, I would say, these three. I think the efforts in studying should definitely go into these and make sure you nail these. And then obviously these two, like 8%, is also very important. But yeah, I would always like focus on the biggest first and then work my way down. Awesome. And yeah, I just had all of these tabs open, just reading all of the different things that you need to know before the exam. So yeah, pass is 80%, and you should get your results there and then, is it? Scored automatically, and a score report will be sent via email. Oh, okay, so it's like the Solutions Architect Associate exam as well. Cool. And then what else have we got? These are exam instructions. Okay, so the Kubernetes and Cloud Native Associate exam is delivered online. 60 multiple choice questions. Oh, that's a bit scary. That's a bit worrying, actually. I don't know. I feel like I haven't sat an exam in a while, and 60 sounds like a lot of questions. Oh, I don't know if I'm ready now. I don't know if this is making me feel more panicked than maybe I should not do this. Maybe I should, well, at least I'm learning it now, right? So, okay. And yeah, results will be emailed 24 hours. Okay, cool. Reliable internet. Sure, yeah, I sort of have a semi-reliable internet, I think. So that's cool. System requirements. Yeah, I've done all of that before. Yeah, testing location, clear walls, lighting, well lit. What do you think? Does this look like a well lit area with my hands? You can see my hands and surrounding. Oh, I'm scared of them judging my plants now. Do you think they'll see it tomorrow? Not tomorrow, but whenever I take the exam, like, oh no. I hope they don't judge my plants. Okay, anyways, yeah, ID requirements. Yeah, cool, awesome. Frequently asked questions. Okay, cool, yep. Just answered all that already. Yeah, 90 minutes. Oh, a score of 75%. I thought it was 80. Huh, fair enough. Okay, cool. Oh, I can see some people on the chat. Hey, Matt. Hey, Eddie. Thanks for joining. I'm literally just talking to myself for the next few minutes, just going through my notes. And yeah, and trying out my fancy new camera as well. Okay, so yeah, and then this is the agreement. Cool. That seems really, really good. I think I'm pretty set. Okay. So like I said, this is the course that I went through. And yeah, I did it, like I said, in 5 hours or so. So it's worth just going through the material again. So these are my notes. And yeah, like I did last time with the the Solutions Architect Associate exam, I'm just going to go and sit here, read through my notes, and maybe, I don't know, maybe we'll do something more practical on a Gitpod workspace or something. But I think right now I'm just going to read through it, make sure I understand it in my head. And when I say things out loud, it normally sticks. So we're going to try it like that. And yeah, the camera looks cool. Yes, thanks, Eddie. I'm glad you think it looks cool. It's just the light right now, it's not great. I should really close the blinds or something whenever I stream, because the light varies a lot, and it just, like I said earlier, I have like a massive monitor, so it blocks like half of the sun, and then the other half just goes straight into my eyes and my forehead, as you can see. And now it's just really bright. Cool. Thanks for the tip. I'm going to go do the Essentials course today. Thanks, Real Cheese. Thanks for joining. Got to grab coffee now. It's just about 6 a.m. I've also got a coffee, look. I've got a parrot in my mug right now. Maybe that's why my brain keeps freezing, because I haven't really had coffee yet. I'm just freezing. You're right, Eddie. The varying I am such a noob at live streaming, clearly, because I was just like, I want to see the window sort of from here, so I'll just keep it open. Although right now there is a storm in the UK, so it is raining and bright sunshine right now. So it's all sorts of things. Okay, amazing. So what we'll do now is we'll just talk through this. All right, cool. So the first part of this was, like I said in the course, is around the cloud native like architecture. What is it? It's just an introduction on what cloud native is and why it's important, essentially. So in this case, I've put here, so what is cloud native architecture? Cloud native is about structuring teams, culture, and technology to utilize automation and architectures to manage complex and unlock velocity. So essentially, the aim of cloud native architecture is to improve productivity, because if our cloud native architecture is designed correctly and we utilize automation efforts, then as engineers, as developers, we should just have a better time. I think it also links into developer experience quite well. So how do you build cloud native applications? I've put DevOps and Agile, microservices. So yeah, I think microservices is the big one. Whenever I thought about cloud native applications, I always thought about like that big diagram that circulates on Twitter of all the different cloud native tools and how they talk to each other and how they sort of integrate with each other. Oh, it's getting so bright in here, isn't it? Okay, that's fine. We're gonna keep it like that. It's cool. And then, and yes, so that's what I essentially see it. So we should be able to describe cloud native applications. Okay, I think that was just a quick introduction of just to understand and put us in the right place. And so let's move on to the open standards. This is what I was talking about earlier. So earlier I was talking about Docker, Podman, and then there's other like containerization open standards that the CNCF community look at a lot. So in this case, we've got open standards, and these are cloud native technologies, mean that there are no vendor lock-in and everyone can collaborate. Most of them are open source. Oh gosh, it is so bright in here. Give me 1 second. I can't deal with it. Okay, I'm back. Oh yeah, okay, so that's so much better. I actually had to turn off my ring light as well because it was way too bright. Okay, that's way better. You can see, yeah, I can actually see my face. Hi Brenda, nice to see you here. Thanks for joining. Just me ranting to myself. What, Eddie, wow, that is so bright. Are you sure you're not here in Bali? Nope, I wish I was. I mean, look at what I'm wearing. Oh, I might actually turn my light on because it's gotten a bit too dark. See, now the sun's gone. I bet the sun has gone and I just switched off one of my main sources of lighting here. So, yeah, okay. Yes. Mirrorless cameras have amazing sensors and need less light. You know what? I'm really embarrassed that I don't know much about mirrorless cameras, even though I had one for years, which was the Sony Alpha 5000, and also the Sony, and then I also got the Canon G7X Mark II. I don't know if that is mirrorless, but I don't know much about them. All this time I've just been like pointing and shooting and just hoping for the best, and most of the time it's okay. But now that when I started researching this camera, this Canon M50 Mark II, I was like, oh my gosh, I don't know anything about cameras and I should probably learn about the different like ISO and different settings. I need to learn that. So yeah, I don't know. I do need to get better at that because I don't know what I'm doing. But I think this is almost semi-default settings right now. And so yeah, it should be okay. All right. Okay. So open standards. Yeah, that was what I was talking about. Essentially, most cloud native architectures are open source, and they like sort of aren't locked into a vendor, which is good, which is a good thing, because if they're locked into a vendor, then I guess you have less flexibility, let's say. And yes, Eddie, there is so much to learn. Yeah. Yeah, because most of the time you just want to put everything on auto and hope for the best. That's literally my approach towards things. So yeah, hoping that hoping I learn this in the next few like weeks or years or whatever. Okay, so yeah, and also, like it said, more flexibility and open standard, easy to implement industry-wide standards as well. Oh yeah, this is what I meant earlier when I was talking about Docker and Podman. So we have in the cloud native space, we have the Open Container Initiative, which is the open source, it's like an initiative that tries to have an open source version of Docker. They try and, because right now Docker sort of dominates the space in the containerization space, and what this initiative tries to do is tries to standardize it, including like the runtime, spelled runtime wrong there, image distribution, and all of that. There's also other open standards like this that exist in the cloud native ecosystem. You've got the OCI spec, container network interface. See, every time I read that word, my brain just stops. Like, I can't read it without being like, huh, what do you mean? Anything networking related, you'll probably learn as I talk to myself that I just really struggle to understand it. Anyways, so container network interface is another open standard. We've also got container runtime interface, service mesh interface, and storage interface. And essentially all of these different things are the open standards. And it's important to know that, especially if you stay in the CNCF community and the different ecosystem, that most of these are open and they prefer things being open, I guess. And then there's also the TOC committee, the Technical Oversight Committee, that maintains the vision and approves new projects and common practices that should be part of CNCF projects. So that includes just like all of the standards. I guess they maintain that and make sure that the new projects that come into the ecosystem sort of abide to that rule. And I actually know a few people in the TOC committee, which is pretty cool. And I've spoken to a few of them. They're really cool people. Everyone's really lovely. Okay, I think that's the introduction of what open native applications are and the open source, the cloud native communities and how they're sort of set up. And yeah, the next bit is container orchestration. So container orchestration is more of the Kubernetes side of things. And I think, like we pointed out here earlier, container orchestration is really important to talk about. It's 22%. So let's go back to basics. What is a container and why is it so useful? So yeah, what I did as part of these things, as you can see in my notes, is I split them all up in chapters and then had the objectives per chapter and wrote notes underneath each one. So as you can see that in this objective, our objective 1 is to explain what a container is and how it differs from virtual machines, and then getting started with running containers and all of that. Okay, so let's start with what a container is. So container technology is actually very old. I found this very interesting, by the way, because when I first started, everyone was talking about Docker. When I first started in the DevOps and platform space, everyone was talking about Docker as if it was like a new thing, and I needed to like jump on top of it to like make the most out of it and learn. But essentially, actually, it's very old. So like the technologies in it is very old. So for example, you've got the ch root, chroot. I always say it out loud as chroot, which is really just not, that's not right. I think that's not right at all. But but it's there. And I'm just checking everything's good. Yeah, awesome. And yeah, so this command is used to isolate a process from the root file system and hides all files. So like bin, etc, home, var from the process. Yeah, that makes sense to me. I think I didn't actually, I have to admit, I didn't actually know much about the different our file system and all the sort of hidden files and the hidden folders until like about 2019 when I was back in my platform team, and I learned that actually, hey, that's a thing that exists. So yeah, always learning. But yeah, so the Linux kernels take this a step further by using namespaces. So essentially, chroot. Is that how you say it? Chroot. Correct me, anyone who's listening. Correct me if I'm wrong. But yeah, this chroot. Now I need to know, before I continue this live stream, I need to know how to pronounce. How do you pronounce chroot? Truth. Oh. Like truth, but truth. Okay. I wouldn't know that. I wouldn't have known that at all. We've learned something together here. Okay. Okay, truth, yeah. The truth command. So yeah, that's a way of isolating processes. But then Linux kernels take that a step further by using namespaces and C groups that continue to isolate resources. This actually reminds me of conversations we've had at Gitpod. Similar technologies used there to isolate the resources a bit more. So for example, a network namespace separates network interfaces and routing tables, so all processes have its own IP address. Currently, Linux kernels have 8 namespaces. I hope we don't have to remember all of these 8 namespaces, but PID, net, mount, is that mount, MNT, IPC, user, UTS, C groups, and time. Okay, and the most important one there is C groups, which organizes processes into groups and assigns them resources like memory and CPU. So if an application container wants a limit of 4 gigabytes, you can use C groups for this. So yeah, I remember seeing a diagram actually on here about it, just to, no, not that. I think it was container orchestration, running container basics. Oh yeah, this is a really good diagram. I should probably try and put this on in my notes, but this is a good diagram to see what the, let me just hide this. Yeah, there you go. To sort of understand it a lot better. So you can see that truth separates the processes. I like how they called it jail process A and jail process B. It really brings home the fact that it's it like separates them both from each other, like they're a jail, so you can't find them, you can't access them, they're isolated. And then I'm guessing a C group is a similar thing. Yeah, so new in namespace that allows a process to have its own set of C group root directories. Yeah, okay. Whereas, so that's like container technology, whereas virtual machine emulates a complete machine. So that includes OS and the kernel, whereas containers share the kernel of the host machine. So if you run Docker on your Mac, Docker uses your Mac kernel, which is why if you have a MacBook Pro or any MacBook with fans and you try and run Docker, you could just hear the fans go off. So yeah, that's because Docker uses your OS kernel. Awesome. And then what else do we have here? And yeah, containers are isolated processes, as we explained up here as well. And you can get started with running containers. You can use Docker using Docker run nginx, and nginx can be any image you want, and images can be found on Docker Hub. Yeah, we sort of know that already, but I can show you like just to demonstrate. And this is me talking to myself and trying to learn it as well myself. So let's have a look. We're just opening a Gitpod workspace. I know that Gitpod is a great place to play around with these sorts of things, but I know that running Docker on Gitpod, not Docker, so I was going to say Kubernetes. Let's move on to that like later in the session, I think. Awesome. Cool. And oh, I can see that Tom. Hey Tom, thanks for joining. Yeah, I'm just doing a bit of studying for the KCNA cert. Okay, so yeah, let's just try this out just to see it. We can learn together. So yeah, I'm running a Gitpod workspace. It's a bit meta because Gitpod itself is a container. Yeah, let's not go into that, into the details there. But yeah, as you can see, I've just run Docker. I've done a Docker run nginx, and this is an image that lives in Docker Hub. And you can see that in my workspace, it says, hey, I can't find the image locally, so I will pull it from Docker Hub, and then you can see it all pulling there. And then once it's pulled, it's sort of, it's started to run. I've got the nginx server working. Tom, braver than me? What do you mean? Like braver than you doing this KCNA cert? I mean, it is very. I don't know. I'm scared. I'm worried. I sort of came in here. I was like, yeah, I could do this, but then I read that it has 60 questions. I'm like, I don't know if I can. 60 questions of trying to get into my head of like what's going on, and yeah, I don't know. We'll see how that goes. Kubernetes and a cert. I hate certs. Yeah, you know what? If I'm being honest with you, the only reason I continue to keep an eye out on certs is because I genuinely find the structure helps me focus, because I think, well, this isn't like confirmed by someone in the medical field or whatever, but I do relate to people who have ADHD, and I haven't confirmed it at all that I have ADHD, but I think I do, just because based on the amount of things that the common behaviors of someone who has ADHD, I really just sort of relate to. So yeah, I haven't had that confirmed or anything. But yeah, the reason I like certs is because otherwise, if I didn't have the structure, I would literally just go off and try and learn everything at once. Whereas a cert sort of like focuses you. It's like, hey, these are the things that you need to know. And then once you finish all these things, you can go off and learn something else. Like you can almost like apply what you learned from the cert to other things. And that's what I did when I did my AWS Solutions Architect course. Like after I did that, I was so much more confident using AWS day to day, because I had learned like literally the ins and outs of certain services. So I was like, I know how to do that. And yeah, Brenda, you said Docker seems so interesting, but so much to learn. Yeah, it is. I'm still learning myself, but you know, the more you play with it, like, I don't know, use Gitpod to experiment and not do it on your local machine, because it will just fill up your machine with random images and containers, then yeah, I really highly recommend that you check it out and like play around with it. I think there are things that I understand about Docker, but I think especially around the networking side, I'm really, really bad at that. Like when someone asks me, how can I connect this Docker container with another Docker container, my brain literally melts and I'm like, I have no idea. I have no idea where to even point you to. Maybe a configuration file on your Docker Compose, I don't know. But yeah, Tom, you said, yeah, I enjoy structured learning. I just never do the exams. That makes me laugh because I thought of doing that before, but then I remember I spent like 3 months learning the AWS Solutions Architect exam, and I was like, oh my God, that would be such a waste if I just don't do anything else with it. So I was like, might as well get the cert and then apply it to my day-to-day job when I was like working with AWS more like full time. Nowadays at Gitpod, we use Google Cloud Platform, and there's basics of like cloud technologies, so and similar services there that I sort of brought from AWS, but I'm not as familiar. Maybe I should do a cert on that. Next on my list. Okay, so we've got this running, and I think you can do a Docker PS. What this does is it just shows you the image that you've downloaded and the status of the container. So you can see it's running on port 80 in TCP. It's been up for 4 minutes. Wow, have I been talking for 4 minutes after I created the container? I must have done. And yeah, this is the command in the container. Cool, and then that's the container ID. And as you can see, the command docker run detach gives you a container that runs in the background, so that now that you do a Docker PS, you should see that container running. So yeah, essentially this is a hanging process right now. But if I didn't want to do that, so if I just canceled that and exited, and then now I do a Docker PS, you can see nothing's running. And if I wanted to have all of that in one terminal, I could just go like docker run detach and then publish all of these flags with any command line tool. I don't know what they mean most of the time, and I don't memorize them. I literally Google it. I sometimes forget the Docker PS command. I'm actually surprised I remembered it this time, because I just don't remember it most of the time, and I have to Google what's that command that shows you all of the images. So as you can see, it's something is running now in the background. So if now in the same terminal we don't have a process that's running, like not running at all, we can do a Docker PS, and you can see that it's the same thing, completely running in the background. And then you should see the server. I wonder if I can run this on Gitpod. I haven't actually tested. What would I have to do? Now if you open, you should see. So if I do nginx, does that open it up? Oh, it does, cool. So if I do open preview, which is up here, yay, it works. It says 404 not found, but hey, it works. Cool, great, awesome. That's awesome. Okay, cool. It doesn't, yeah, awesome. And now if you want to stop this container, so we'll do a docker stop, and then we'll get this container ID. Oh yeah, that's the same ID as that. Okay, cool. And then we do that. Okay, then that's a bit weird to me. Like, why would it output? I guess that's just a confirmation. Like, yeah, stopped it. That's a bit confusing. It should say something more human readable, like, yes, we have stopped your Docker container, and then the ID. Something like that. That would be cool. Okay, so then now if we do a Docker PS, we can see it stopped, and then we can also do we try an nginx. And it says that it could not bind addresses in use. And also, it's not even open, so it shouldn't even work. Okay, cool. Amazing. And then, yeah, so if we continue in the Docker space, so container images makes containers portable and easy to reuse on a variety of different systems. It contains everything you need to run an application, code, runtime, system tools, system libraries, and settings. I remember actually, that triggered a memory in my brain, but when I first joined, when I first became a platform engineer, I had a similar, I kept asking people what Docker was, because it wasn't widely used in my company, and I kept asking people, and they kept saying like, it's like a container, like the things that like runs on the ship and stuff. They're like, what do you call it? Yeah, they're ships, and they're like, it's a container just full of everything you need. And it just still didn't, I just still didn't understand, like, because I kept imagining, like, so if you put your source code on this container and you update the source code, would you then need to update the container image? It doesn't make much sense to me, because in my personal project, I update the source code like every day because I find a typo or something. So I was like, why would they put it in the Docker container? But then maybe for an individual's use, it doesn't really make much sense. But then now I see it at a larger scale, it does make more sense. So yeah, that's good. Cool. And yeah, so images are built by reading instructions from a Docker file. Let me just check that. Why is it still running? That's really confusing, because I thought I stopped it. Do I have two running or something? I don't really get it. But okay, I guess maybe that's a Gitpod thing? Oh wait, do I have another one? No, that's not my Gitpod configuration. Okay, I'm not too sure what happened there. Okay, anyways, so if you want to create a Docker image, you can create one in the command line and have like docker build t my custom image f Docker file. I thought I got all of the things. Docker build and then building an image from Docker. Yeah, I thought that was it. Let's have a read. Oh, I meant help. Could be cache. Oh yeah, it could be Tom, thanks. Yeah, not 100% sure, but we will find out, I'm sure. So -t, which tags it, right? What's the required options? Path, and I don't get it. Why doesn't that work? That's what I thought. Oh, is that because I need to create a Docker file? Am I being an idiot? Let's have a look. I reckon that is it. Let me just remove this. You can upload all of the Docker images. Oh yeah, I do need to create a Docker file because I haven't built my brain, duh. Okay, of course, duh. Okay, so yeah, I need to create a Docker file. And then these are the different options of building your own Docker file. So from which uses a base image, run, work directory, set the working directory, copy, run. Oh, I don't know, I have run twice there, but run, and then CMD, which is the default processes that starts when you run Docker run. Okay, cool. The Docker, and then you do Docker build, and then you tag your image, and then from the file of the Docker file. Cool. And yeah, so some of you may be like, oh, why is this set up? Why do you have a Gitpod Docker file? Because it's a similar concept with Gitpod. So when you start a new workspace and you want to have your own custom Docker image, you can build on top of the Gitpod workspace full image. And that workspace full image literally has everything installed already. And we're an open source company, so you can actually check out the source code and all the tools that are already set up in the workspace image. But in this case, in this case, I was doing like a demo where I was showing like you can do a sudo apt update and then install Cowsay, which isn't installed in the default image, and it makes it your custom image. Similar thing with this, apart from I think apart from like obviously it's not set up the same way, so it's not .gitpod or whatever. It's just a Docker file, but essentially you can do anything here. You can run any package. You can, I don't know, I think you can even do a git pull of source code or whatever it is, whatever you need to be productive. I think I'm so used to the way Gitpod has set this up that I just forgot what it's like in the real world. Oh, Brenda. So Brenda, you've asked a question. Are you using your M1 MacBook Air to stream? Yes, I am. The most efficient MacBook ever. I don't have any fans on it. I just touched it. It's not hot. It's a bit warm. It's a bit warm, I have to admit, but that's welcome because it's so cold in here. But yeah, it is just that. And also I started using OBS, which is this platform that we're on. Oh, it's so bright again because of the sun. Let me just switch that off. Okay, that's my ring light off. I don't know if that makes much of a difference. It's so annoying. It's so annoying how I don't have full control of this light. That's frustrating. But yeah, so I am using my M1 MacBook Air to stream and connected to my mirrorless camera and then my Elgato mic. You probably can't see it. There you go. That's my Elgato mic. It's running amazing. It's running on AWS, on OBS, and it's just incredible. Cool. So yeah, we know that. So you can also follow OCI runtime spec standard. The Open Container Initiative maintains a container runtime reference called runc, and you can use Podman, which is like Docker, but it has more features, and it runs on the Open Container Initiative. Security. So yeah, we have until this section. I might do another separate live stream or something with about Kubernetes. I think we'll see, or I might come back on later. But essentially security. So there's a security risk running containers with too many privileges, like rooted admin. And another security risk is making sure that image don't have malicious software in them. Because, yeah, that's really important. People can just throw in anything into a Docker container and it could sort of hide under the radar. So it is important not to just pull images from a random Docker hub that doesn't have many pulls or anything. It's just a random suspicious Docker hub image. So yeah, that is very, very important. Brenda, you've asked, how is the laptop? I'm so indecisive over an M1 Mac Mini or M1 laptop. Okay, so my 2 cents. I'm dark again because of the sun. So annoying. But yeah, in terms of which I would get, so I got the M1 Air because I like being at my desk, but I also enjoy just sitting anywhere in my apartment. So sometimes I sit on the kitchen table, the kitchen counter, the dining room table. Sometimes I lay on the couch. Sometimes I go out in my balcony on a beanbag. Sometimes I work from bed. So I just need the laptop because I needed the flexibility of just going anywhere and it would just continue. But then the M1 Mini, even though it's super powerful and, you have extra ports and stuff, I was like, it doesn't really make sense for me to have that when I like moving around a lot. And, when I travel, I was, because I work at GitPod and it's 100% remote. And because it's 100% remote, I can literally work from anywhere. And I was just imagining that, like, even though the Mac Mini, you can just throw it in your bag and whatever. I was like, I need a monitor. I need to hold a monitor with me. It doesn't make much sense. So I was like, the laptop should do. I can't really show you this, my laptop, because it's all plugged in. And if I like move it, it might unplug itself. But yeah, it's a really good M1 Air. And also another thing, another reason I got the M1 Air is because I knew I was joining GitPod. Okay, this is like a game now. I'm just switching lights on and off. But yeah, I knew I was going to join GitPod, and because of GitPod, as you know, the product is so lightweight, and I don't need to have an editor that I have to install onto my machine. So I was like, hey, I don't, that's like my previous life now. I'm living in the future. I'm just using GitPod workspaces to code, which I use full time. Why do I need a super powerful machine? So I was like, I'll just go for the cheapest Air. I actually got the base model, which is £999. And that is like, in my books, such a steal because of how expensive the new ones are, the M1 Max Pro chips or whatever it is. So yeah, it's like incredible. I think it's, genuinely changed my life, like the way GitPod works and the way I've worked. So I just, like, I was really tempted by the new machines. I'm not going to lie. I was like, oh, I'm going to buy one, I think. But then I had just bought the Air and I didn't fancy spending another like couple £1,000, like just replacing something that was already working. Oh my gosh, this lighting. I am annoyed. It's the sun. This is the UK in general. This is a good example of the UK. So So yeah, so that's essentially my choice. I could go on. You know what? That's a video. Tom, you're right. I need to do a setup tour. You're 100% correct there. So true. So important. Wow, that definitely is a steal. I'm going to look into it. I've never used Gitpod, but I'm convinced I will try it out. Yay! I'm glad. If you have any questions, feel free to ask me. I'm happy to help you out, like get set up and stuff. Because I know, like, as engineers and developers, this is turning into a Gitpod stream. Dang it, it always does. But with Gitpod, I think it's one of those things that just, like, when you've been working locally for so long, you sort of just accept that that's the only way you can work. But now, like, I was skeptical at first. I was like, I'm not sure if people would want to adopt this because everyone loves their local machine. But then now I've deep dive into the technology of Gitpod and I've seen it myself. Like, I went to London a couple of weeks ago and I needed to work from London, but because it was sort of a stressful day, I didn't want to bring my laptop, even though it is a really light laptop, I just didn't want to bring it. So I just brought my iPad, which is this. This is my iPad mini. And as you can see, it says open in Gitpod. It's a nice sticker, but my iPad is all I used when I was away. I was on the road. I wasn't driving, but I was just on the road. And then I was like out and about and moving a lot, and sometimes I have a few hours to sit down and do some work, but I just had my iPad mini. And there was even one time I was in the tube and then I got out to take the fast train from the tube to Watford train station, to the station that then takes you to Watford where I was staying, and that because I hate London. and yeah, so we were staying there, and then like I just had my phone. And someone pinged me at work and was like, someone in the community pinged me and was like, I need help with this thing. It's not working on my workspace. And I was like, send me the link to your workspace and I'll try and figure it out for you. They shared, that's another beautiful thing with Gitpod. You can easily collaborate and share things. So I just took their link that they shared with me. I opened that link on my phone. So this is my phone. I rotated it to be horizontal and I was like this. I was like typing on my phone, like typing in the terminal to see why it wasn't working. Found the bug. Turns out it was their code, not Gitpod. But yeah, it just shows you, like, can you imagine? Like, this is like the future. You're working in the future. In the future, people are going to be talking all about cloud developer environments, but then they don't, working from their phone, from their iPad. But I think, we might have a bit more to go before the wider market adopts it, but it's so exciting to be like at the forefront of it. But yeah, let me know if you have any more questions about Gitpod. More than happy to help you out there. But yeah, get the M1 Air. Yeah, that one. And I've seen, Tom, you said, I'm still waiting for an M1 Max to be delivered. Defo never going to use it to its full potential. Yeah, the thing is, oh my gosh, this lighting. I'm so sorry, everyone. I swear, I'm not normally such a noob with these things. But yeah, so with the M1 Max, like, the only reason I would buy it is that black keyboard. Can you imagine? Like, I waste so much power because I like the way the keyboard looks. That's the amount of money I would spend just because of the keyboard. I've done stupid stuff like that in the past, so I wouldn't be surprised if I continue to do stupid stuff like that. But yeah, I haven't done it just because I was like, I use Gitpod. There's literally no need for me I don't need a powerful machine. I do like a lot of content creation, so I could have justified it from that point of view, but it's still not as good. Like, I don't think, like, my M1 is amazing with Adobe Premiere Pro. I edit all my videos in there. I use Photoshop on the daily. I use OBS to stream. It's perfect. It's fine. Like I said, still warm, still going, and we've been on this stream for a long time. So, yeah, totally get that though. On that note, we'll move back to here. So yeah, security is super important, and then fundamentals of container orchestration. So having lots of loosely coupled containers, so microservice architectures. If you deploy large amounts of containers, you'll quickly get to a point where you need a system that helps with the management of these containers. For example, scheduling containers, providing compute resources, for example, virtual machines where containers can run and allocate that. And that, my friends, is Kubernetes. Intro to Kubernetes. And container orchestration systems have two parts. This is specifically Kubernetes, but they try to keep it as neutral as possible. So container orchestration systems have two parts: a control plane, which is responsible for the management of all the containers, and then you have the worker nodes, which actually host the containers. It's really like meta, and I still get confused. So you've got like your worker nodes, you've got in your worker nodes, you've got the containers, and then the applications are inside the containers. But even before that, before you get into a container, you've got a pod, because the pod creates the container, and then the container has the app. It's just like, what? So many abstractions. It's like, oh, you really do need to think through it because it's so complicated. And there are some challenges with like, oh yeah, this is container networking and storage. This is where my brain switches off. But essentially, microservices implements an interface that can be used to make a request. So each microservice has a little interface that can be used to make a request. Network namespaces allow containers to have its own IP address, so that if an application has the same network port that works, all ports on port 8080, it allows, so you've got a namespace, and inside that namespace, all the containers have its own IP address, and if an application in that all works, oh, okay, yeah, okay, that makes sense, yeah, sure, okay. And then when you want to communicate to other containers, you have an overlay network that puts them in a virtual network spanned across the host system. Oh yeah, okay. Okay, great, cool. And then there's a standard called the Container Network Interface, as we discussed earlier, which can be used to write and configure network plugins. This is why I don't think I could like just do networking, because it's so confusing. Like, I don't know, so much there. I hope you can still see my screen. Yeah, I think you can. Yes. Oh, it might not be that clear because of the streaming software. Okay, we can sort that out. And then explain the benefits of a service mesh. So we've got proxy, manages network traffic and allows communication between services. Most popular service meshes are Istio and Linked. Proxies in a service mesh, which is the data plane. Oh, it's just so confusing. Oh, I'm just like I'm not enjoying this. It's very confusing. Let me just have a look. Like, maybe we can get an image of it or something. So control service mesh. I'm on the wrong browser. Maybe I should like increase this as well. Oh God, it's way too. Oh God, so confusing. Let's visit the Nginx because we've given them a lot of love. So service mesh is configurable low latency infrastructure designed to handle a high volume of network-based. Oh gosh, that's just not clear. Why is nothing like written in clear English in tech? It's not great. Oh, here's a good picture. Oh, so inside the control plane, as part of the Kubernetes or orchestration system, it has, oh, okay. So inside the control plane, there's service mesh, control plane, and that defines flows from service A to B. So it basically does all of this, like it shows how the different services connect to each other and how they, sort of talk to each other. Okay, cool. And cool. And you have the proxy, which manages traffic to allow communication between services, which you can see here. I need to download this image because this is really good. I'm going to put that on my notes, I think, so I don't forget. So this could be Istio. This could be the Istio. Cool. You write a config file where you tell the mesh, A and B should always be encrypted. Is there like a Istio like config file? Like, I'd like to see what that looks like. So just because I'm curious. Like, can I have like an actual file though? Not. Is there like one file that does it all? Oh. Okay. Get pods. So you, okay. Yeah, that sort of makes sense. Okay, cool. So that file, that config file where you specify what talks to what, it should always be encrypted. And then you've got storage, which is containers or ephemeral. So storage is tough. Yes, I get that. I get a similar thing right now with Gitpod where because it's of its ephemeral nature, you need to make sure that you're mindful of where the files are and where they live, because they need to live under workspace, which is backed up. So yeah, that makes sense in that sense. But so it says here with storage, sometimes the best thing to do is you can create a volume and that can persist it, so it's not part of the whole system. Then to share data across different containers, you can use a storage system. So like a volume, like on AWS, an EBS volume, and then a storage system would be the file system thing that they have on AWS, which is also a service that they can have. Awesome. Cool. So I actually feel like I can go on for a few more minutes, maybe 20 more minutes. So I might go through this part. Oh gosh, I didn't remember it was this long. Let's go through a bit of Kubernetes. So we have, what is Kubernetes? That is a question. Someone actually asked that on a podcast I was on recently, and I was like, let my colleague Jeff answer that one, because it's so, there's just so many things going on to try and explain that in a nutshell. But yeah, that's how it goes, isn't it? Okay, I hope you can still see my my stream going. I just had a look at my stream and I refreshed it and it looks like it's really poor quality. Maybe I should improve that, like, for next time, because it doesn't seem like the camera looks good, but like my screen sharing isn't great. Let me just increase that. Maybe that'll be better. So yeah, Kubernetes. What is Kubernetes? That is the question. Container orchestration platform that can be used to automate deployment, scaling, and the management of containers. So we talked briefly about that up here. container orchestration. And it was originally developed by Google, and Kubernetes, oh gosh, was open sourced in 2014. I didn't actually know it was like developed by Google until recently, and yeah, it sort of surprised me that they separated themselves from Google and is more of a, it feels like it's a more of a standalone product, a standalone tool that isn't associated with Kubernetes, with Google at all these days. I guess that's what happens when it sort of evolves over time. But yeah, so discuss the basic architecture of Kubernetes. So when you think of Kubernetes, I put equals cluster, think of a cluster. And the components of Kubernetes that make up the cluster are, like I said earlier, the control plane node. So we'll just make that bold, control plane node that manages the Kubernetes cluster and controls tasks like deployment, scheduling, self-healing of containerized workloads. And yeah, that makes sense. That's the bit of everything. That's the that it's basically the brain of Kubernetes, and it's the brain of Kubernetes that does all of the like meaty deploying and scheduling and all of that. Example services inside the control plane are the Kube API server. Everything interacts with this. etcd data, which is the database that holds the state of the cluster. Kube scheduler, which schedules worker nodes based on CPU and memory. And then Kube controller manager, which manages the state of cluster with control loops. So that manages the state, but etcd holds the state. Okay. Then cloud controller manager, which is an optional thing that links to other cloud providers, I'm guessing, and it creates external resources like load balancers and storage or security groups. Awesome. And so worker nodes, this is where the applications run, as I explained earlier. You've got container runtime, which runs the containers inside the worker nodes. You've got kubelet, which talks to the API server in the control plane, and container runtime to handle final stages of starting containers. You've also got kube proxy, which is the network proxy that handles inside and outside communication of your cluster. Replies on OS. I don't know what that means. Kube proxy, network proxy that handles inside and outside communication of your cluster. Yeah, that makes sense. What does this? It feels like an autocorrect thing. I don't feel like I wrote that. Does that make sense? Might just remove that for now. And then, so yeah, those are the main ones, main sections. So you've got control plane, that is the brain. It has all of these things. Let's just make them bold so we remember them. etc, Q, and controller. Cool. Let's also actually get a Kubernetes control plane. Oh, this is a good image. I've seen this before. Yeah, as you can see, you've got the control plane, the cloud provider API, which again, you can create different load balancers or other cloud resources. And you've also got the worker nodes, and the worker nodes have the actual containers and where the applications actually runs. And this also has kubelet, which actually talks to the API server. Oh yeah, that makes sense. It looks better when it's when I can see it in an image. I'm a very visual learner, so that's just how it sort of works for me. Let me just save this image. I wonder if the no, can I not just drag this? So annoying. Okay, can I drag it from? Oh, is it an SVG? Does that work? Just like, oh, that's really annoying actually. Come on, logseek. How do we do this? Can I just take a screenshot maybe? Let me just go on control plane. And then I've got this. Does that work? Oh, nice. Okay, cool. Yeah, okay. From now on, we're taking screenshots. Okay, so awesome. And yeah, as you can see, that's basically the whole architecture. You've also got namespaces, which divides a cluster into multiple virtual clusters. It's used for multi-latency when multiple teams share a cluster, but it's not good for strong isolation, and view it like a directory on a computer. I love that saying. That's the best one I've seen. So no, not Namecheap. We're going to put namespaces. It'd be nice to visually see it. So if we go on Namespaces Kubernetes, oh yeah, okay, you can sort of see it here. Is there an even clearer one that maybe has the same style of this one so we don't get confused? Oh gosh, that's AWS related. Let's not look at that. Oh, that looks a bit... I just wish everyone had like consistent diagrams. That would be nice, wouldn't it? Oh my gosh, what is this? Oh my gosh, I feel like this is what I've been needing this whole time. Communication between containers on the same pod. Oh my gosh, I'm saving this. I'm very excited about this. Let me just add it to my notes. Oh wait, I don't need to add it on my actual notes. I can just put it here. Let me just put it up here. I need to clean up my notes actually. Awesome, that looks really good. Great, okay, so then we go on to, let's just pick a nice one. Like, is there an image of a whole cluster and then the namespaces? Ah, this one. This is the type of image I'm looking for. Yes, this one. So if we go on here and just paste that in. So it divides into multiple clusters. It's not good for strong isolation, but as you can see here, we've got one Kubernetes cluster. This is one worker node. It zooms into the worker node, and then you have these different namespaces that just separates them into multiple virtual clusters, and yeah, and then you can see the containers in each of them. So yeah, this is app one. You have the pod object, Kubernetes object. And yeah, no, that's really cool. And then kubectl, which is the Kubernetes API, allows users to create services, modify, delete, retrieve resources in Kubernetes. It does this by this workflow. So you authenticate the requester, authorize the user based on the RBAC role, which is role-based control, and then admission control allows, oh yeah, and then it allows to modify and validate the request, and then they go ahead and do that. Awesome. And yeah, I think that's pretty good there. Explain the different components. Yeah, that's one of the objectives. I should probably move that up there because I feel like, yeah, let me just cut that and move that up here. Understand how to get started with the Kubernetes setup. Discuss how Kubernetes is running containers. So getting started with the setup, I think if we go on learn Kubernetes in 15 minutes. So if we go on documentation, is this essentially talking about, yeah, downloading Kubernetes, kubectl? Yeah, I think that actually is related here. So I'm going to remove, oh no, oh yeah, cool. So you can get started with Kubernetes by using the kubectl, which is the Kubernetes API, and it uses this workflow. Let's make that a bit clearer. You authenticate the person, so someone runs like kubectl get pods, what the API does is it sees if the requester can actually run this command, or like who the requester is, and then if the requester has the role-based control that says, yeah, it can run a get pods on this cluster, it allows it, and then that's what the admission control, and it says, yeah, sure, you can go ahead and modify the request or do whatever you want, really, which is cool. And then you have discuss how Kubernetes is running containers. And yeah, we've sort of covered this in our initial diagram above, but Kubernetes supports other container runtimes. Example, containerd, CRI-O, and Docker. Containerd and CRI makes it easier to run containers on Kubernetes than with Docker, not then. Than with Docker. And to start a container, you need to create a Kubernetes pod, and then which makes the container. Yeah, I'm quite familiar with that because, as I said, I actually tried to do the certified Kubernetes application developer exam. Well, at least prepare for it. And as part of that, I did a lot of pod creating. It was so many YAML files specifying the different things that you need to create a pod. So yeah, quite familiar with that. Discuss scheduling concepts of Kubernetes. So subcategory of container orchestration that describes the process of automatically choosing the right worker node to run a containerized workload on. So, this is done by the kube scheduler, which is inside the control plane, I believe. Let's have a look at our diagram again. Control plane. Yeah, scheduler. There you go. So it's inside our control plane. Let me just make that a bit bold. And we can sort of see it on here, I think. Schedule. Is that what that is? Schedule. Yeah. The schedule is in the control plane. Cool. So then it does that, but it just schedules the containers. So the scheduler inside the control plane just schedules the containers on where they're going to go inside the worker nodes, but it's not responsible for starting the actual workload, i.e. starting the containers or running them or whatever. It just schedules them. And it schedules users information users specify about the loads and schedules to nodes with the least amount of pods. Yeah, and that makes sense. Now I want to know, I seem to remember in the documentation, was it a schedule YAML file or something? Oh, do you stateful sets? I feel like, oh no, it was a deployment. Does that use the scheduler? No, that deploys the actual containers. See, this is why. So it seems really quite straightforward, but what was I going to say? Like the certified Kubernetes application developer exam, they actually, for those who don't know, they actually allow you to read the documentation. You have like full access to it, so you can go through it, but it's like finding what you're trying to look for that's stressful and a bit like, I'll spend half of my time just going through the documentation and trying to read it if I don't know where I'm going. I'm pretty sure that there's a way to schedule your workloads. Do I talk about it on here? Oh, maybe I do in working with Kubernetes. Now I really need to know. Schedule Kubernetes, because how does the kube scheduler do it? The kube scheduler is a control plane process which assigns pods to nodes. Yeah. How do you do that? How does it do it? Is there like a config file? Oh, is it just kubectl? Oh, I guess so. Is it just using the I don't need to deep dive into this for this exam, for the Kubernetes and Cloud Native Associate exam. Literally, they don't really care. But I just really want to know. I need to see it. I need to see it in action. I thought there was like a YAML file or something. Clearly not. Okay, yeah, I think it sounds like, yeah, you just use this API. You just use the API kube scheduler to schedule it. I've actually not scheduled a pod on Kubernetes before. I think I did have like a deployment. I did do a deployment on Kubernetes once where I I created a deployment file and then deployed the pods from that deployment file. So yeah, maybe that's what is confusing me, because I'm trying to understand the difference between scheduling and deployment, I guess. But okay, cool. Yeah, that seems about right. And then, oh gosh, networking. This is the last part of this section, so I'm gonna smash through it. But here we go. This is where my brain stops to work, and we will be here for another 2 hours. But so we've got networking. So containers, the containers that are in the worker nodes at this point. So the containers need to connect to other containers in the other nodes. So Kubernetes helps with networking by, you can do containers to container communication, which is solved by the pod concepts, and we actually go into that a bit more later on in my notes. But yeah, so you can do container to container communications, and I think the pods can do that. Is it like a pod YAML file? I just need to see what it looks like, because I think you can add a pod. Yeah, so this is what the pod YAML file looks like. It's a simple pod one. I guess you can set ports, and you can say this is the container port, and I guess there's other configuration that you can do for each container to talk to each other. You just have to specify it in this YAML file, I think. And so, yeah, and then you also have pod-to-pod communication. Okay, now I'm confused, because you can have several pod files, all of them creating its own container, or several containers, because that's what pods do. And then they can talk to each other using another thing, which is an overlay network, which is called an overlay network. Okay. Then you can also have a pod to service, which is another Kubernetes object. And this is done by kube proxy, which is in the control plane. Kube proxy? No, it's in the worker nodes. Okay, kube proxy is on the worker nodes. Okay. Yeah, kube proxy and packet filter on the node also, and then external to service communication. So you've got a service YAML file or a service Kubernetes object, and for that to talk to the external world, which I'm guessing means outside of the cluster, then again you can use kube proxy and packet filter to the node. So the requirements for networking in Kubernetes is all pods communicate with each other across nodes. So again, these are the different nodes, and all of the pods inside each node should be able to talk to each other. All nodes communicate with all pods, so the nodes themselves can talk to the pods. And then no network address translation. Oh yeah, no NAT. Was it NAT? I think it was. Yeah, I think that's what that means. Oh, now I need to double check, because I don't want to get that wrong. Yeah. Oh my gosh, look at this. How is anyone supposed to understand what this means? It's so confusing. Just reading that, it's well confusing. I've no idea. Yeah, okay, so NAT. So that's just the basic requirements of networking in Kubernetes, and something I guess we should just be aware of. So all pods should be able to communicate with each other, and all nodes should be able to communicate with all the pods. Yeah, okay. And you could implement networking using these different, I think these are cloud native tools, networking specific tools. Every pod gets its own IP address, so there is no manual configuration involved. So when I deploy a pod, it has its own IP address, and the way for another pod in a different node to then talk to that initial pod, it does it by specifying the IP address. Is that how it works? And then core DNS is, core DNS is a service add-on. Core DNS is a service add-on, so it's an add-on. It's not a. that helps provide service discovery and name resolution inside the cluster. So it helps find different services inside the cluster and how they name resolution. I'm guessing that refers to the name, the thing that connects the object to something in the cluster. Is that what that means? I'm guessing now is also a good time to open this up again, which is Kubernetes networking for beginners. Oh, here you go. There are 5 essential things you need to learn about networking in Kubernetes. Let's just quickly smash this out. So I've got 3 here. What's the other 2? Communication between containers in the same pod. Oh, okay, let me add that. So containers should communicate with each other in the same pod, or be able to. Communication between pods on the same node. Not across node, but on the same node. Communication between pods on a and different nodes. So I got it correct the first time. Communicate between pods and services. Pods and services communicate. And how does DNS work, and how do we discover IP addresses? So we've got here a cluster with 2 different nodes and 2 different pods with its own set of containers. Communication between containers in the same pod. So you've got 2 containers inside the pod. How do they talk to each other? This happens via local host and port numbers, just like you're running multiple servers on your laptop. This is possible because containers in the same pod are the same network namespace. Oh. Same network namespace. Is that different to a normal namespace? Okay. It's a collection of network interfaces. Okay, namespaces are useful because you can have many network namespaces on the same virtual machine. There's a secret container that runs on every pod on Kubernetes. This container's #1 job is to keep namespaces open in case all the other containers on the pods die. It's called the pause container. So each pod gets its own namespace. Oh, okay. This network namespace then allows the communication between the 2 containers in the pod. And in this case, you have a network bridge for different pods. This is so helpful. Oh my gosh. So for a container to speak to another container in a different pod, you need a network bridge. Ah, okay. And then how about pods on different nodes? What do you use here? Oh, cool. Okay. Oh, pods and services use kubeproxy. Every service in a cluster is assigned a domain like, okay. Oh, okay. Okay, that's really helpful. So I'm just going to write this down. So container to container. Network namespace. Communication between pods on the same node. Overlay network, that's what it means. I guess it didn't go into detail for this course because I didn't want to stress anybody out. Okay. So network bridge, communication between pods on different nodes. Or different nodes by Oh, okay, so it's a similar thing. By changing route table. Okay, and then pods and services is kube proxy. Then external to service. Kube proxy. Okay, cool. Right, that was very good. What is this? Learn kube faster. Get the #1 guide. Thank you, Matthew Palmer. Do I know you? No, I don't, but oh, I do. I do. You created the vanilla thing. I actually used that on my Mac. That's really cool. Now I want to have this book. Oh my God, I thought it was like $70,000 then. I wasn't going to pay $70,000 for a book. $29, that's okay. Become a Kubernetes expert in a week. I'm not sure about that, but... Oh, maybe I can use this for my next exam. Okay, cool. Well, keep that in the back of my mind. Amazing. And I think we've reached the end. Wow, I've been streaming for 1 hour and 35 minutes. Oh my gosh, that was super useful. I think it was good going through all of the different concepts again. It is very high level, I think, and I think I do know more than I think I know. So yeah, I'm definitely going to go through working with Kubernetes and all of these different concepts again. Maybe I'll do another stream, perhaps. But yeah, I need to go through all of the different concepts again. But I think I'm good. This is the first time I'm going to be doing a different certification that's not like AWS. So I'm not sure if it's going to be similar style type questions, similar style type sim style type questions, or like style. So we'll see how it goes. I'll try and sit it soon and then get through it, I guess. We'll see how it all goes. But thank you so much for everyone who has tuned in. Like, so many of you have dropped in and out, but it's been nice engaging with you on the chat. Thank you so much. Cool. I am going to have some lunch. Have a nice day, everyone.